One of the solutions to the CFIT problem is proper training. Let's look at a training situation in the simulator where crews learn to avoid CFIT as well as perform the escape maneuver.
Before takeoff, the crew completed a departure review and briefing. Here we see them as they're going through the approach briefing. The common thread running through CFIT accidents is situational awareness. This includes not only horizontal awareness, knowing where you are over the ground, but vertical awareness as well.
We have a crossing restriction at 10,000 feet and 250 knots right here at Bonneville.
Approach charts should be studied before leaving cruise altitude. Key fixes and airport elevation must be noted and associated with terrain and obstacles along the approach path. Pilots should have a good understanding of both approach and departure design criteria in order to fully understand the obstacle clearance margins built into them. Some captains have spent hours studying a first-time approach into a terrain-critical airport. Terrain and obstructions should be studied using a chart that shows elevation contours, preferably a chart with color. Know your altitude and distance from the landing airport. Cross-check the altitudes with the approach charts or en route maps.
1,000 above.
Cross-check.
Understand that you are responsible for knowing this information, not the air traffic controller. Most modern airplanes use electronic displays that show your position. This information is a great help, but remember, errors can occur. Make sure that the navigational radios are properly set. Several CFIT accidents have occurred because the pilot was flying an instrument approach while the navigational radios were incorrectly tuned. If your airplane has a flight management computer, make sure it is correctly programmed. Each pilot should independently verify the information entered into the computer. During the approach on most airplanes, the pilots must carefully monitor raw data from the VOR, DME, or NDB, as well as information from the barometric and radio altimeter. Use every available aid to assist you in knowing your position and the recommended altitude at that position. Hazards exist using low descent quadrant or step-down approaches. When authorized, a continuous descent angle of approximately 3 degrees is an effective way to fly a stabilized non-precision approach. Studies show that one of the common factors in CFIT accidents is the lack of a stabilized approach. Operators considered the safest in the business all have procedures about when an approach must be stabilized and what the crew should do if it is not. These same operators also have well-defined standard operating procedures.
500 above.
Check.
Communication is the key. Each pilot must have situational awareness to ensure the final descent path is correct. If any flight deck member is unsure, execute a missed approach.
Minimums.
One of the solutions to the CFIT problem is classroom instruction and simulator training for the crews. Training needs to include not only CFIT causes and traps, but recovery as well.
Based upon extensive simulator studies, we've found that unless daylight visual verification is made that no hazard exists, the proper CFIT escape maneuver is: react immediately to a GPWS warning without hesitation. Positively apply max thrust and rotate to the appropriate pitch attitude for your airplane. Pull up with wings level to ensure maximum airplane performance. Always respect stick shaker.
Pull up. Max power.
870, rapidly decreasing. 560, decreasing.